Hello and welcome to Tutorial 1 Part 2. So we have Excel open. The first thing I'm going to do is I'm going to go down to the Help menu and I'm going to bring up both the instruction manual, like so, and I'm also going to build up the demonstration workbook. So I briefly talked about the demonstration workbook in Part 1. It's worth looking at carefully. But the aim of this exercise is to recreate the demonstration workbook from scratch using the template that is supplied with the Platemaker Wizard. So that is what we're going to do. So if you go to the instruction manual, you go down to the table of contents, you'll see Tutorial 1 Part 2, Replicating the Demonstration Workbook. Click on this and we can begin the exercise together. So the next thing we're going to do is to build the workbook with the template. So we do this by simply going up to add-ins. Now because I have an activated version of the wizard, I need to first put my program into tutorial mode. You don't need to do this if you haven't purchased the program yet. And then we go down to template editor and I want the Ovarian Cancer Screen Demonstration template. I push run template and it will build this particular workbook, which it's doing at the moment. So we'll wait for it to do this. And there you have it. So now you can see the plate maps. And if we compare this workbook build to the demonstration workbook, you will see that they essentially are the same. The only difference is this workbook doesn't have all the data analysis that this workbook has. So let me show you what I mean. So we can see this one has plate maps. If we go to the plate maps page, you can see it's exactly the same. I'll just zoom out for you. See, it's exactly the same plate maps. And you can see that the new workbook has the text maps, the flat data file, and the two containers where we're going to add our data. Whereas the built workbook, obviously all this information is now complete. So if we go to here, we can see the information has been entered. So the exercise today is to pretty much recreate this workbook. So let's begin. So the first thing we need to do is import the data that comes shipped with the Platemaker Wizard for this particular workbook so we can start to do the analysis. And the way we do this, as we learnt in the first part of this tutorial, we simply go to Documents, we go through the Platemaker Wizard shortcut, and then we go to Tutorial, we go Import Practice Data, and then we have a whole series of different formats of our data which demonstrate the different ways you can import the data. So if I go back to the instruction manual, you will see that in terms of importing the data, the exercise I want you to do is to use the cell count and cell death CSV files, as this is probably the most likely way your machine will return data to you. However, I'm going to do it a different way. I'm actually going to do it using plate 1, 2, and 3. So this is exactly the same data, just in a slightly different format. And what I've tried to do here is imagine the different ways a plate reading machine can return the data. And this demonstrates that the import function that is supplied with this program can pretty much cope with any format that your machine returns data in. So we're going to show you this now. So as I say, you are going to open up cell count CSV and cell death CSV. I'm going to open up plate 1, plate 2, and plate 3. So I'm going to do it a slightly different way. So let me show you what I mean. So we're going to go back to the thing. There's my plate 1, plate 2, and plate 3. And I'm simply going to select all three. A little Excel tip, if I right click and click open, and this will open all three plates simultaneously, which we're doing now. So you can see all three plates are opened, and in my example you can see that each plate contains a single plate of data for cell count and for cell death. So we're going to use this format to import the data into the demonstration workbook that we've just built. You're going to do it slightly differently because your example has a single CSV file of cell counts with the plates under each other and a single cell depth CSV file with the plates underneath each other. But again, it's explained very clearly in the tutorial down here. Okay, so I'm going to go add-ins, I'm going to go import data, and you can see that I have 3 source workbooks open. So obviously you want the plate 1 to start with. I want it to start at cell count. I need to match the first cells. It's actually B2. So there's 2 ways I can do this. I can either just type B2 and you can see it goes up that way. Or the other way I can do it is to right click and go into the workbook and then move this to the right cell as I've done here. So it's now B2. There is no space between the plates because there's only 1 plate, so this is irrelevant for this particular exercise for me, although it is for you. And then I'm going to move it into the, not to the demonstration workbook, that's the workbook that is already open, it's the other one, isn't it? It's the Ovarian Cancer Screen Demonstration Workbook. I want cell count, it will be B7. And then it's a multi-source, multi-reading input. And the reason it's this is each plate is a different workbook. So I need to select workbook and then I need to match up. So plate 1 goes to plate 1, then plate 2 goes to plate 2, and plate 3 goes to plate 3. And also I want to import multiple readings. So the multiple readings the multiple readings are found in the worksheet. So I push worksheets and now I have cell count to cell count, cell death to cell death. So that's matched up. I want to close all my source workbooks after import, so I click there and I click import, and you can see when I do that it is now imported the 3 plates worth of data into the cell count and the 3 plates worth of data into the cell depth. So it's that easy. Now, as I say, your exercise will be slightly different, but you should be able to work through that using the clear instructions in the Platemaker tutorial. Okay, so once you've worked through that, this is being explained here. Okay, so you work through all of this. We then come to adding a Z prime page. So that will be the next thing that we'll do in our exercise. And in fact, in honor of that exercise, I think I'll grow a beard. Right, so the first thing we're going to do is we're going to add a Z prime page. And for those of you who don't know what a Z prime is, I don't really want to explain it here. This is a very common test that's used in high content screening or this type of work, where in general, if you're doing some sort of drug screen, you tend to load the plate with quite a few positive and negative controls. And this is a way of making sure that the assay window is adequate enough to actually have meaningful data. So it's just a very quick way to make sure the experiment has actually worked, that your negative control is truly negative and your positive control is truly positive, and they're well separated so that you know that you have a viable assay. You can look at the formulas, that's the formula there, that's how it works. But we're just going to simply now create a Z prime page which will give a summary of the Z primes for each plate. So let's do that. So we go Platemaker, we go down to calculate Z primes, we click on this, and the first thing we're going to do is we need to put in the negative control area. So if we go on to the negative control area, we then right click our mouse and it'll take us to the plate maps page, and quite conveniently the way this experiment is designed is the negative controls are in this central column here and the positive controls are next to it. So what we can do is we can use any of these plate maps to select the negative control. I'll just use this one, so I'm going to select my negative control area. I click OK and it puts the negative control area into the negative control place. Note, this is not this particular set of addresses. This is actually on a plate map. It's actually gone back to the master plates and remapped it so that you get the right address, the right area. The positive control area, again, we right click and we simply select the positive control area like so. And we only want the Z prime for cell death. That's the only meaningful one we're looking at. So we simply put in add cell death. So we put that in there. And then we can click OK and to calculate our Z primes. So we'll do that. And you can see that the assay has been okay. It's been pretty good for the second. That's a really good Z prime for the second plate. It's okay for the third plate, but there's a problem in the first plate. So it might be worth trying to work out what's gone wrong on the first plate. So let's do that. So what we're going to do, so again, let's go back to the instructions. So if you flick back to here, I've just done that for you. If you're following along, there we are. We've just created our Z prime page. And we're now going to examine why the first plate we have a Z prime that's failed. So there's something wrong with the first plate. There's something wrong with control. So let's look at that. So if I go across to the flat data table, as I've done now, and actually we already have the negative and positive controls for plate 1 showing because they're at the front in the way the flat data table works. So I'm just going to select cell death because that's the relevant Z prime point that was calculated from these data. And you can see that if we look at the positive controls on plate 1, they're all nice and high. The negative controls, you can see they're quite high. Just to explain, this particular assay was originally derived by taking ascites drains from chemotherapy patients with ovarian cancer. So there is quite a high background cell death in these experiments, which is why, incidentally, in the flat data table, we are using two different calculations to subtract off the background cell death and rescale, which is the cell death normalized. So what we're going to do is, if we look at these data, we can see that there are two very high cell death data points. And normally you might say, okay, well, we should reject the plate. Of course, this is a tutorial, so we're not going to reject the plate. We're just going to remove those data points. You can imagine that maybe they could be legitimately caused on a high content screening experiment by a piece of crud fluorescent junk in the well, which would then dramatically elevate the measurement of cell death and also throw the cell count data. So let's pretend that that's what's caused that, and let's get rid of these data so that we can demonstrate to you how to use the cell cleaning part of the Platemaker Wizard. So what I'm going to do now is I only want to remove data that is in the DMSO negative control. So the way I'm going to do that is I'm also going to select this filter, and I only want to select DMSO, which I've now done. And so now I just have the DMSO data for the cell death, which is the negative control data. And if we flick over to the crib sheet, you will see that in your instructions, we are going to remove all the cell death data that is above 70%. So let's do that. So we go Platemaker, we go clean data, we want to select cell death, and we want to change it to greater than 70%. Now, when you do any sort of clean in data, the information is logged onto the experimental details page. So what we want to do here is we want to make sure that we communicate what filters were set on the flat data file so that when that information is logged on the experimental details page, the correct filter settings are also transferred. So the important filter setting for us is the fact that it was the DMSO data that was being dealt with and nothing else. So it's not a general data clean, it's only removing values which are greater than 70% in the DMSO compounds wells. Now, we could just remove cell death, but in this situation it might be that the fluorescent piece of junk is transmitting high fluorescence across all the different fields, in which case it may also be contaminating the cell count field, giving a very, very erroneous cell counts. So what we want to do is we not only want to remove the data from cell death, we also want to remove it from cell count. So the way we do that is we're going to propagate the data removal so that it actually propagates across all the measured variables of the experiment, which in this experiment is cell death and cell count. However, you'll notice that we've set already a filter on just cell death, so we can't see cell count. So if we just had DMSO and we did not have this filter set, we could just run it and would remove the cell count data. But because we have this filter set as well, we need to ignore the flat data filters, the dependent data filters, when propagating to get it to also delete the cell count data. So we've clicked that button and we're ready to run it. So we simply click remove data. And as soon as we do that, you'll see that now the cell death data has been removed. And if I take all the filters off, you'll see the cell count data has also been removed. And it's been removed from here, but if we go to the raw data, you can see that the data hasn't been deleted from the plate, but it has been highlighted in red. So we can see the values on column 12 in the DMSO column that have been highlighted in red. These are no longer included in our flat data analysis table. This also means that if we want to, we can reverse the process and put the data back should we decide that we've made a mistake and we want to restore it to the flat data table. So now that we have removed the data, if we now go to the experimental details page and we click view and we click headings and we drag out this row here, we can also see how the cleaning program has added the record that we removed, cell date death that's greater than 70% in the DMSO wells, which is there. So you can see it's keeping a complete audit trail of the various data cleaning options that we used when we did our data analysis. So that's part one of data cleaning. We're now going to move on to doing some visualization of the data. So if we go back to our data crib sheet, we've done all of this. We're now going to add a heat map page. So the way we do this is we go back to Platemaker, we go create statistical summary page, and what we want to do is we want to create a heat map where we have all the compounds in rows and the doses in columns, and we want to make it so that for something like cell death, as the death rises, it goes from green to red. So we're going to put compound in the row, we're going to put dose in the column, we're going to click create heat map. We're then going to put the negative control name, which is DMSO for the negative control, and it's benzothenium chloride for the positive control. And because I've done this before, you can see it's remembered that I've done this before, which is why I can select it. If you're doing it for the first time, you have to manually type it in, but every time you type in a value in any drop-down list, it is always saved for future use by the Platemaker Wizard. The other values, I'm just going to move to the filter so I have them so I can play around with them if I want to. I'm going to set the page magnification at 50%, and as I said, I want a one-way red high so that it goes from green to red as the values increase. I now click OK, and I've created my first heat map. And now this heat map is meaningless because at the moment it's just an average of all the data of all the different measured variables. But if I now select cell death normalized, you can see I now get the cell death normalized data. These are all the compounds. I can make it slightly larger. These are all the compounds. You can see compounds like bortezomib are very, very potent, whereas other compounds like etoposide clearly have absolutely no response. So you get a basic heat map, and the control, DMSO plate control and benzothenium chloride positive control have been moved to the bottom of the table as shown. So that is the exercise that you've just done. If you're following along in your crib sheet on tutorial 1, you would have just done this exercise. I'm actually going to do a second heat map which is not in your exercises, but just to show you a very similar heat map, taking advantage of the class variable that is also included in this experiment. So if I go to plate maps, you'll see that this is the compound, but we have one further designation which is class, and it's either standard therapy or other therapy or negative or positive control. So let's go back to here and we go create statistical summary table, and this time I'm going to put class into row and also compound into row. I'm going to put dose into column and still a heat map. Now this time it is basically going to group the compounds by class. So class is now to the furthest of the left inside the groupings. So we want to move the negative and positive control down to the bottom, but now we're using the class as the qualifier. So rather than DMSO, we now just call it negative control because that's the name in the class. And the positive control name in the class is positive control. It's still a one-way red high. We'll still do 50%. We'll click OK, and now we have almost the identical table, but now the compounds are reordered in alphabetical order but also grouped into classes. And again, if I just change the dependent variable to cell death normalized, you can see I get a very similar heat map to the one before, but now I have the compounds ordered in class. So again, there are different ways of using the program to generate different heat maps. Okay, so if we now go back to our tutorial, we've done the adding the heat map page. We're now ready to move on to creating our first statistical summary table, which we're going to use to generate prism graphs of our data. So what we want to do is we want to basically generate the dose response curves for every one of these compounds as a separate graph so that we can see the individual dose response curves. And just to show you how we're going to do this, what I'm going to do is if you go back to the Platemaker Wizard data and you go to graph templates, you can see there are 3 templates that are included, and these are just standard Prism graph files with the program. I'm just going to click on single graph template for a minute just to show you what I've done here. So I created this basic Prism graph file to be a container for all the different dose response curves of this particular experiment. And you can see that the way it works is it's a logarithmic scale. So the doses are 1, 10, 100, 1,000, 10,000. And then the 0 has been cheekily recoded to 1 times 10 to the minus 10. And I've used the Prism graph multiple axes to create an axis break. So obviously the reason for doing this is you want it on a log scale to get the dose response. But what you can't do is put 0 on the log scale because 0 is undefined. So all I've done is put an axis break so I can create an artificial 0. But because it's mathematically it's on a log scale, you have to recode that to 1 times 10 to the minus 10 or something which is a positive value, because obviously 0 is not possible to plot 0 on a log scale. So that's exactly what I've done. Okay, so that's how I deal with the dose response. You may want to deal with it a different way. This is just how I do it, and obviously the particular exercise that we're about to do, we're going to use these particular templates. So this is the first template that I've created. Now I could just use that template and add all the graphs, and that's fine. But what we want to do is, if you remember the demonstration workbook, we actually had inside the demonstration workbook all the graphs nicely laid out, and we did that using Prism graph layouts. So what I've also done is there's a second graph file program which is 56 drug layout graphs, and if I open that one, it's exactly the same, except this time it already has the 56 different worksheets to create the 56 different graphs, which at the moment are completely empty because there's no data. But the reason this one's good is because I've already created the necessary layouts to take all these 56 different graphs once the data's put in there. And you'll see how we're going to use this template in a moment. So now we know what we're going to do. We're now going to go back to create statistical summary. And this time what we want is we want to create a table which we can use to export the data to create those dose response curves. So you can see that when you look at the pivot table maker, there are 3 different areas, and what I've helpfully done is also in brackets put how those 3 areas are going to relate to the graph. So anything that goes into rows of the table will become the x-axis of the graph. So we're going to do a dose response curve, so the obvious thing we want to put in there is the dose. Now we can also put in the dose dimension, and that's useful because then it will automatically set the dimension inside the graph title so that you've actually got the dimension of the drug. So we'll put that in there as well. Now we only want a single dose response, so nothing is going to go into columns, because how columns translates, if you put multiple columns, and we'll do this in the next exercise, is you end up creating multiple plots. Okay, but we just want a single plot on the graph, so we're not going to have anything in columns. But we are going to put in filters, we do want compounds, because what we want to do, so this is like the graph heading, so we want a separate graph for each compound. So that goes into filter, and we put that up there. And finally, we've got these other 3. So what we'll do is we can move those into filter as well if we want. And then if you look at the original template, the way it's set up is it just wants the mean and standard error of mean. So I want the mean and standard error of mean, so I'm going to calculate the standard error of mean. That's what I need to give it. And also for data cleaning purposes, I actually want to create an individual table of sample repeats, which I'm going to click here. So this is what we need. So we're ready to generate this. Now I just click OK. And you can see that it has generated the necessary tables to create what I need to export to Prism Graph. So first of all, this is the statistical summary table with the mean and SEM and the doses that will go to Prism Graph. And this is all the individual values. Now at the moment this is meaningless because this is an average of count and cell death and all the other variables. But if I click over to say cell death normalized, then you'll see that now this is cell death normalized. Again though, this is the average across all the different compounds. So if I now select bleomycin, this is the data, the 3 repeats. So this is across the 3 plates for bleomycin data for cell death normalized. What I need to do now is I really want to have some way of flicking through each of these filters, and there's 56 of them, so this will take quite a bit of time. I want to then copy these data and move it to Prism Graph. But in fact, I also want the 0 dose in every single table. So what I really want is to also switch on, using multiple selections, DMSO as well, like this, going from one to another drug, while keeping the DMSO value fixed, so that that's the 0 dose for all the different graphs. But I've told you that we can't put 0 on a log scale, so we also need to recode that. And if you remember, I told you we coded that as 1 times 10 to the minus 10. So the first thing I want to do is I want to change this so that when that reads 0, when that value is equal to 0, it actually recodes it to 1 times 10 to the minus 10. But if it's not 0, then it needs to show whatever value it is. So I can do that with this useful little function called add to formula. So I can simply click add to formula. And you can see that the first thing it does is it picks up where the cell that this formula is referring to. And now I can simply say, okay, if AA equals 0, then I want you to make it equal to 1 exponent minus 10. That's the way you write 1 times 10 to the minus 10. And then I want to do that if that's true, so I simply click OK, and you can see that now it reads 1 times 10 to the minus 10, which is exactly what I want. Notice that if it doesn't equal 0, if I release the DMSO, which I can do here, then it'll go back to 1. So we've got exactly what we need now. So let's think about what the program needs to do next. We needed the program to be switching each of these filters behind the scenes to create each individual table. And then this little table then needs to be captured in a file. It then needs to be sent across to Prism Graph, and it needs to be sent across with a script file that tells Prism Graph what to do with the data. And the Platemaker Wizard can do all of that, and it does that with the program Generate Prism Graphs. So how does this program work? So firstly, you'll see that it's picked up all the dependent variables that are available on this page. Now, if you leave the dependent variables in the filter, whatever they're set at, it will leave alone. So for instance, if we don't select plate number, then that filter is just left on all. If we don't select dependent, then that would just be left on cell death normalized. So whatever the filters are set, they will just stay as is. However, if we move these filters into these tables, either into the y-axis title of the Prism graph or the main title, then the program will start switching the values of each filter behind the scenes, capturing the resultant data, and then exporting it to Prism Graph. So what do we want to do? First of all, we want to graph every single drug. Remember, the aim is to create a single dose response curve for every single drug. But I've also told you that we want the DMSO 0 dose present. Now at the moment, if I just put this back to all, and I call up the Prism Graph table, and I put compound into main, and I was to run this, behind the scenes, it's just going to switch from each drug, but that means we won't have the 0 dose. We'll only have the 1 nanomolar dose, or whatever the first dose is, and we want the 0, remember. So what we really want for DMSO always to be present like this, and then behind the scenes it's switching each different drug but holding the DMSO present. So the way we communicate this to the Platemaker Wizard is we simply select DMSO. We make sure that the select multiple items is off. If this is on, you'll get an error message, but it's easy to correct. We simply select this so that this is now showing. And then when we run the program and we put compound into the main title, what is going to happen is the DMSO is always present, but behind the scenes it's switching from drug to drug to drug to drug, creating the table, which it then exports for graphing in Prism Graph. So that's the first step of what we have to do. Now, I also would like to graph simultaneously all these different dependent variables. So I'd like to graph cell count normalize, cell death normalize, and cell demise. So how do I do that? Well, all I need to do is put the filter back to all. So this now is just an average. But when I select Generate Prism Graph, I'm going to put compound into the main title. And this time I'm going to put dependent into the y-axis. So now what it's going to do is the main title will have the different compounds, which is what we want. And it'll generate all the different graphs where the dependent variable now becomes the y-axis title, which is what you want. Okay, so we want a measure of cell death, don't we? We want a measure of cell count, and these are all going to be y-axis titles. So it will now, behind the scenes, it's going to be switching to two filters. It'll first go to cell count, and then it's holding DMSO constant, so behind the scenes it's going to go axitinib. It'll take that table, it'll copy that table across to a file area, and then it will create the Prism Graph script file, and it'll import the data into Prism Graph and create the graph. It'll then move to the next file, which is bleomycin, and repeat the process, and so on and so forth. For cell count, when it's completed all of those, it'll then go back to the first drug, but this time it'll then switch across to cell count normalized, and the process will continue. Do you see what's happening here? The important thing to point out is if you try to do this manually, it would take a long time, but with this program in Platemaker Wizard, you can generate all the graphs very quickly from your Excel workbook. So that's what we're going to do now. Now, in your tutorial, you will also see that we do actually want the class compound inside the Prism Graph files. Now, the first time I do this, I'm actually not going to do that, but we're going to run this program twice. And the reason we're going to run it twice is because we're going to run it, we're going to then see what the data looks like, and then we're going to do some further data cleaning. Okay, so that's how we're going to do it. So we're now going to select DMSO, as I instructed before, and that's going to tell the Platemaker Wizard to hold DMSO while skipping through all the other drug data. You would also select the class, which would be negative control, but we're not going to do that just at the moment. And we've put the dependent back to all because we want the wizard to step through that filter as well. So let's now do it. So we're going to go Generate Prism Graphs. I'm going to put compound into the main title. So this means it's going to have, each title is just going to have the compound, but the DMSO is going to be in every single graph, which will be the 0 dose. We're going to put dependent in the y-axis. And if we now sent this to Prism Graph, we would have an incredibly large number of graphs because we'd have 56 different compounds, and then we'd have all the different graphs. And you'll notice that in this situation, we could either send it as y-axis by main title or main title by y-axis. That would be how it would be grouped inside Prism Graph. But that's way too many graphs for Prism to handle. And in fact, if you try and do this as a single operation, the script file that is generated for Prism Graph to execute is too big, and it won't work. So we're going to click this option, which is y-axis parameters to separate Prism files. So what this will do is after it's completed one set of compounds, it'll send it to one Prism Graph file, and then it will create a new Prism Graph file for the next dependent variable, which is what we want. And you'll see this in a minute. Now, the template we want, remember, we want to take advantage of the layout later on, but for now I'm actually going to select the single graph template. Remember, this has only got one graph template, just to show you what that looks like. Again, this is not in your tutorial, there's a few extra things, but it gives you a feel for the way the program can work. So I'm going to select single graph template. So I do need to add graphs to that template because that's only got one graph. If I try not to add it, would crash it because there's only one container in the Prism graph template to receive data. I need 56 or 55. So I leave that unchecked. And from that, I am now ready to go. So remember, the class is left in the pivot filter. That's just going to be left alone, which is fine because we're not worried about classes at the moment, and we're not worried about looking at separate plate numbers either. So I now push generate graphs and the process starts. So behind the scenes, it's now flicking through the first dependent filter, which would be cell count. It's gone through all the compounds, holding DMSO constant. Now it's opened up Prism Graph. You can see Prism Graph is open here. It's running a script file, the first script file, which is adding all the tables that it's generated for all these different snapshot tables of this particular pivot table to Prism Graph, and then all the graphs are being generated, and you'll get to see this at the end. Okay, so it's just done the first one, so that would have been cell count. Behind the scenes, you can't see it working, but behind the scenes it's now doing cell death, and then it'll go to cell death normalized, and so on and so forth. And when this process is finished, we'll generate a whole heap of hyperlinks where we can go into each file that's been created and we can see all the graphs that have been generated. So this is the process that we're doing now. So what I'm going to do is I'm going to pause the video here while it finishes doing its work, and when it's finished we'll come back and see what it's done. Right, so it is now finished, and you can see that it looks exactly the same as it was before, but you'll now see that we have these hyperlinks that have been created at the top of the statistical summary page. And if I go into the most interesting one, which will be cell death normalized, you will see that this opens up a Prism graph file. So you can see, remember, our template just had a single data table. Now we have all the data tables have been created for each individual drug. And if we go down to graph, we can see we have the different individual graphs of each drug. This is cell death normalized. This is the dose response. Remember, the zero dose has been recoded to 1 × 10⁻⁻10 to fit my template, and it's all worked beautifully. Okay, we don't in this point have the necessary layouts because I haven't used that particular template, but if I wanted to generate the layouts I could, but you can see we can quickly step through and see all the different graphs it's generated. If I look at cell death rather than cell death normalized, this will also give you a feel for what that formula is doing. Cell death, if I look at these graphs, you can see the only difference is that we have a much higher cell death background. So cell death normalized, what it's doing is it's actually subtracting off the zero dose background and then rescaling. And that's just what we were doing with this particular assay, because as explained earlier, patient ascites fluid, the cell death is already reasonably high as a background, so we need to subtract that off. But the assay still worked fine when we were doing it, as you can see from the cell death normalized data. The one change I do have to make, though, is on cell count, because the template, the y-axis is set from 0 to 100, and of course cell count is not fixed from 0 to 100. So if I go into this one, and I just go to any graph, it appears that there's no data, but it has worked. It's just that it's off the scale because it's 0 to 100. So the way we fix that is just using standard Prism graph functionality. So if I just go to the first graph and I simply double click it, and you should know how to do this. This is not really part of the Platemaker Wizard, but I'll do it anyway. Just put that to an automatically determine the range and interval. Click OK. It's now fixed, and Prism graph has this very handy wand feature, so I need to select all the other graphs. I need to give it time just to select them. It's done that there, and then I simply go to the wand, and all I need to do is to tell it to fix all the other graphs to the setting of the first graph that I haven't selected. So I just select that one. I click next, and I have to be a bit patient and wait here for it to do it. You can see it adjusting all different graphs, so we just give it a few seconds to do that. It's a bit memory intensive, I think, so you can see it working away. We'll just give it a few seconds to do that. I think it's finished, so we just click OK. And voila, in a minute you'll see all the graphs for cell count have all the axes have been adjusted. As I say, this is just a prism graph thing. There they are, they're all adjusted, and now they're all working, so all is well. Again, I'll just save that as well. So now we come to cleaning the data. So if we go back to our instructions, if you're following along, you would have done it slightly differently in that you would have had the class filter, which I'm going to do at the very end for you. So don't worry, I'm actually going to show you how to do that. If you don't know how to do it, you can just follow what I've done, and you can do it twice like I've done. But again, I haven't bothered writing all these extra steps in. They're just bits of extras that's in this video. This is just describing rescaling the cell count. We're now up to cleaning data part 2. So let's do that. So what we're going to do is we're going to open the hyperlink. Now, we haven't got the layouts because we didn't use, remember, the 56 template layout. But 3 compounds that have problems are carmustine, cladribine, and olaparib. If there's a few more, but these are the 3 that I use as an example. So the carmustine one just has a very large error bar, whereas these 2 seem to have this strange anomaly at the 1 nanomolar. Now, before we go any further, this instruction video and manual is teaching you how to use the different functionality of the Platemaker Wizard. Now, if you saw this, you may have a good understanding of what's going on, and it may be appropriate to remove that data. However, by no means am I teaching you to just throw out data willy-nilly using the Platemaker Wizard because it doesn't quite fit your hypotheses. And in fact, I really strongly recommend you read this footnote about this, because in fact there was a really interesting real example in my own scientific career where we were looking at the stimulation of downstream ERK in the presence of EGFR inhibitors, and it turned out that the low dose inhibitor was actually stimulating ERK phosphorylation. You might think, well, how is that possible? Well, it turned out that at very low doses you were getting the dimerization of the receptor because the inhibitor caused the dimerization of the EGFR receptor, but both ATP sites weren't blocked, so you're actually getting a leak. So in fact, sometimes strange anomalous results can be real biology, really trying to tell you something. So I just say that because I don't want people to think that I'm somehow a scientist who just throws out data when it doesn't fit my hypotheses. But obviously, in this example, we are trying to teach you how to use the wizard. So obviously, we're just using toy examples of how to correct data. Okay, so with that said, the aim is to just throw out this 1 nanomolar high point here and this 1 nanomolar high point here, so this will flatten off. Okay, so we're just going to do that. So we have cladribine and we have olaparib. So how we do this is we go back to the flat data table here, and we first of all, if we have any filters set at the top, so if you had like DMSO set, which you probably had before, the first thing you need to do is to release any old filters. So let's just release all the filters. So you can tell when all the filters are turned off because this goes back to a standard black. If you have any filters on, you'll see this is blue. So make sure all the filters are off so the full table is available. And then what we need to do is we need to select our 2 drugs, which is cladribine and olaparib. So we go up to here and we select cladribine, which is here, and olaparib, so it's in alphabetic order, LMNO, olaparib, which is here. So now we have these 2, and remember we also want the 1 nanomolar dose, so we simply go to 1 nanomolar, and you can see that all these cells turn to blue, and you can see there's a massive skip, so we only can see these data. All right, so we're now ready to take out the 1 nanomolar olaparib and cladribine data. So we simply go to our clean data function again, and what we want to do is this time we are not selecting on any value. We actually want just to remove that data that can be seen that's currently showing in the flat data table. So we use the special global character, and that tells the Platemaker Wizard that anything it can see in the flat data file that you can see, it'll take out. So we put the special global character, so we're not filtering on any value. And because it is going to log this particular clean, we want to make sure that we tell the program what filters were set. So the filters that were set were olaparib, so let's type that, olaparib, and cladribine, and it's 1 nanomolar. So we type that there. Now, the question is do we want to propagate? Well, you can look in your instructions, your tutorial, but in this situation, we are not going to propagate because we're just going to assume that the problem is only in cell death. So we're going to unclick the propagate, so it's only going to remove the data in cell death. So we're ready to go, so we simply click remove data. Now we get this warning message, and this warning message is telling us that because we've used the global character, if we have no filters on our flat data table, it literally will remove all the values in cell death. If we had propagate, it would empty the whole table. So it's just warning you, hey, you sure you want to do this? But obviously we have set our filters, so we're quite safe to do that. So we say yes, and when we do that, you will see that it has now taken away all the cell death data, which is what we wanted for both cladribine and olaparib at 1 nanomolar. It hasn't taken the cell count data because remember we asked it not to do that. We said don't propagate, so it's only taken cell death because that was what we had selected. It hasn't taken the cell count normalized because that variable depends on only cell count, but the cell death normalizer is gone because that depends on cell death, and the cell demise formulas are also now empty because that depends both on the cell count and the cell death. So that is our second cleaning instructions. So if we now go back to our crib sheet, we've just described that, we've just done exactly here, so we've gone through to here, you should be on this page here. Alright, so that's the first step. Now the second thing we want to do is fix this karmastine data, and this is now based on cherry picking out a faulty value. So remember, if we look at the karmastine graph, it was one very large error. Okay, so let's do that. So what we're going to do now is we want to take the filters off the flat data table because again we want now the cleaning program to have complete access to all the data. So now that the cleaning program has access to the full flat data table, we now just go back to statistical summary, and this time we want to select karmastine. So we're going to move this to karmastine, which is our relevant drug, and we also want the relevant dependent variable, which of course is cell death. And as soon as we do that, we can see that our problematic data point is data point 1. So we just want to remove this data point. So we simply put the cursor on that data point, and once more we are going to select the clean data function. But I'm also just going to show you another trick that can be used when you're doing lots and lots of work like this, is you can also use keyboard shortcuts. So if you look on the Platemaker Wizard, you can see that certain letters in the menu are underlined, and I'll show you what that means. So if I want to select clean data without using the menu, I can go Alt, and as soon as I go Alt, you will see that you start to get these letters appearing, and you can see that the letter for under add-ins is X. So I click X, and now it'll go to the Platemaker Wizard menu, and now I can just select Y, and when I select Y you can see it comes up with the Platemaker Wizard menu, and then the final letter is E, and you can see now I've selected this without actually accessing the menu with the mouse. So again, you can use shortcuts. That is described in the data crib sheet, so you can see that as well. So now we have our menu up for deleting this particular value, and you can see helpfully it picks up the value wherever the cursor is. So you can see we want cell death, which is correct, and we want it equal to, and you can see the value has been copied across. Now at this point, what it's going to do is it's telling the program will go through the flat data table, and it will search for every value that equals this value and delete it in cell death, and if you have propagate, it'll also make sure it does it for cell count. And the data filter is definitely none because it's got access to the whole table. Now you might say, oh, but hang on a minute, what about if we have two values that are equal to that, then we'll delete both values? Then you might say, well, that's going to be a problem, isn't it? And I'm going to tell you it's not. And the reason it's not is because the probability in this experiment of having two values to this number of decimal places is 0. So basically, because it's got so many decimal places, this uniquely identifies that one particular value. However, if you were deleting a value that was only like 20, like a cell count, you might say, well, hang on a minute, that's a problem because there might be more than 120. In that situation, what you can do is you can tick this option, remove single value, and then what it does is as it finds a value in the flat data table, it will switch over to the flat data value, show you that value in its context of the independent variables, and then if you agree to delete it, you push yes and it deletes it. If you say no, then it will skip to the next value, so you can cherry pick which values you need to delete. All this is described in the help. Just push the help. You'll see that all this is described for you in the clean data. So you can see this example I'm using. This is the shortcut keys you can use, and I describe here's describing using the individual remove single value and what that looks like. Okay, but in my situation, as I say, I can confidently delete this without using the remove single value. And we are going to assume that because this value is so off on cell count, that it's probably a piece of fluorescent crud that's also throwing out the cell counts. We're going to ask it to propagate, so we leave this propagate. We don't need to ignore dependent variable flat data filters because we don't have any filters set. So we simply push remove data, and when we do that, it's removed the data. Now, first of all, you might think, well, hang on, it hasn't removed the data, hasn't it not worked because it's still there? But actually, it has removed the data. It's just that the statistical summary pivot table has been cached by Excel. So you need to update the table to indicate what's happened on the flat data table. And the way you do that is you go onto any of these variables here. So let's go to cell death. You right click, you click refresh, and bingo, the value is gone. And so we've corrected that value. Okay, so now you'll see we've completed our 2 exercises where we've deleted our outlier cladribine data, and we've also deleted our carmustine data. So the final thing we want to do is we want to update all our graphs. So we're going to repeat the process of sending the graphs back to Prism Graph. Now, interestingly enough, if I wanted to, I could do this manually. I've got my graphs. I could literally, if I wanted to, go to, say, cell death like this, and I go to carmustine, you can see that there's the large error. Simply copy this manually, now that the large error has been removed, back into here, and the new graph you can see is correct. So I could do it manually if I wanted to, but what I'm actually going to do this time is I'm going to just regenerate all the graphs using the Prism Graph Maker that we used before. So the way I'm going to do this is we've just refreshed the table, so all 3 changes of the 3 drugs has been made, and we're now going to run the program again as we did before, but this time I'm going to use the other template, and I'm going to be following the instructions as per the tutorial 1. So if you follow these instructions, you'll see it's a little bit different. So first of all, what we're going to do is, if you remember, when we first did this, I only had compound in here, and that just generated all the compounds. But now what I want to do is I want to introduce the class variable. So if I go to plate maps, you can see this is the compound variable. There's also a class. So I want to order the compounds by their class. Okay, so I'm going to actually use 2. So let me show you how I do this. So we go back to the statistical summary page, and you can see there's the class. So before we just left the class alone, now I want the Prism Graph to not only put in the title, the compound, but also the class. So it needs to be switching through both. So the first thing I need to do is put this back to all, because remember, I also want it to switch through all the different dependent variables on the y-axis. Remember, I need to hold it with DMSO constant. So do you remember I need to select DMSO, but I'm also now going to include class in the Platemaker Wizard Prism Graph Maker, and because I'm including class, it's now going to switch through this one. Now watch what happens if I have DMSO and I switch, say, other therapy. By definition that's blank because that's incompatible. So remember, I need it to have DMSO and I need to have the negative control. I need both those switched on, so I need it switched like this, so that now this is still always present as it was before. So I need to have both these switched on this time. I need those both set to that to tell the Platemaker Wizard to hold those 2 constant while it switches through behind the scenes all the different compounds in all the different classes. So it's ordered by class and then by compound. So let's do that. So I now go up to here. I go generate prism graphs. So this time I'm going to put class into the main title first and then compound. So the order is how it's grouped. So it's going to group it all by class. So it's going to class 1, which will be the other therapies, and then I'll switch to the next class, standard therapy, and so on and so forth. You'll see this in a minute. The dependent variable, like before, goes back into the y-axis. Remember, I need to send each of the y parameters to a separate file. This time, rather than the single graph template, I want the 56 drug layout graphs so that I also have my layouts already present in the Prism graph file. So I'm going to select this one, which means that now I do not want to add graphs to templates because all the containers are already there. And I'm now ready to go. I've got everything set. So I simply push generate Prism graphs and off it goes. And so behind the scenes, it's doing the exact same thing that it did before, except this time it's using a slightly different template with layouts, and this time the class variable will also be included in the title of the Prism graph. So we'll let it churn away. As I say, it's going to take some time. It's just doing the first one. So remember, it's gone to dependent variable cell count and it's generating the script file for all the tables for cell count. It's just finished that. It's now switched to cell death, and it's going through and generating the 55 compounds for cell death, generating all the tables and adding them to Prism graph. So that's what it's doing. So we'll let it do that and I'll come back when it's finished. Okay, so it's finished. You can see that the hyperlinks have all been reset. And if I go back to cell death normalized, you will see that this time, when you use the one with pre-layout, sometimes you get this error message. Don't worry about this, just click OK because it's absolutely fine. So you can see it's done the exact same thing, but now you can see that the tables have other therapy first. So you can see the class is now included in the title, which is the instructions that you would have been following, but it's exactly the same thing. There's cell death normalize, other therapy, carboplatin, and so on and so forth. And now we have the layouts, and you can see that if we look at the layouts, you can see that olaparib's been fixed, and on layout 2 our problematic 1 nanomolar doses in cladribine's gone, and the other one was carmustine, and you can see that that big error bar's been taken out. So we've finished our data cleaning and we've created our Prism graphs with the corrected data, so all is good. So if we compare now the workbook that we've built so far, the Ovarian Cancer Screen Demonstration Workbook, with the demonstration workbook that's included with the Platemaker Wizard, we can see there's a few extra things. So you can see the big extra things that are still missing are graph pages, graphs for other therapies and graph standard therapies, and an image page with some nice images. All these pages, statistical summary, these are all here, of course. And the final thing that's missing is if we go back to the front page, we have this really cool hyperlink index that allows us to quickly navigate to all the different pages of the workbook. So what we're going to do now is, in this final section of the tutorial, we're going to show you how you can use the Platemaker Wizard to add these final extra pages. So how do we do that? So the first thing we have to do is we have to add some more options to the Platemaker Wizard menu. And the way we do this is we go Program Options, and you will see that in the Program Options menu, there is this Menu Options section where we can switch on and off different utilities of the Platemaker Wizard. The one that we need is Show Page Utilities. So we click on that, we click Finish, and now you'll see that we have 3 new utilities, and these are what we can use to add the final functionality that we need to our Ovarian Screen Demonstration Container Workbook. So the first thing we want to do is, if we go to the statistical summary page, remember we have our hyperlinks to our graphs. So we just want to add the cell death normalized graphs. These ones, rather than have them external to the workbook, we want to put them back into this workbook. So let's open this, and this is the other reason why we have these layouts. They're quite useful because now we can copy 9 graphs at a time to a page inside our container workbook. So let's do that. So the first thing we need to do is we need to create in our container workbook a page to put the graphs in. And you could do this manually. I mean, obviously you can manually add a page, but the Platemaker Wizard has this handy little option, Add Graph Page. So let's do that. So we'll say Add Graph Page, and you can see it adds a little white page already titled graphs. The reason why it's useful to use this is it also puts it in a very specific place, so it'll always locate it straight after the heat maps rather than randomly put it somewhere inside your workbook. So again, it keeps your workbook fairly ordered. So we're going to first of all put the standard therapies in this page. So what we'll do is we'll just rename this. So we'll right click, rename, we'll just call this graphs, and we'll just type standard therapies. Oops, standard therapies. We also want a second graph page for our other therapies. So we'll go up and again we'll go add graph page. You can see it's added a second graph page called graphs 2. We shall once again rename this to graphs other therapies. We'll then flick over to our graphs page, and you can see layout 1, we have our other therapies, so that needs to go in there. So we now simply go copy layout or Control C. We go back to here, we can just go up to a cell here, and we need to paste it. Now here's an important point. When you paste graphs, do not simply just go paste. The reason why is because if you do that, you actually paste an object of Prism Graph inside your Excel container workbook, and that is really problematic because it'll make your container workbook become huge because it's actually replicating all the data that's inside Prism Graph. So you actually only want to paste that particular layout as an image, not as the complete Prism Graph object. So the way you do that is you say paste special, and then you can see rather than paste it as a GraphPad Prism 8 project, you paste it as a picture enhanced meter file, and that's the correct way to paste it. And that way your container workbook won't become absolutely huge in terms of taking up space on your computer. It'll remain a fairly decent sized file. So we've pasted our first set of graphs in, so we just repeat the process. So I'll do a second one. So again, I flick over, layout 2, and again, I can go Control C. I'm going to use the keyboard. I can go back. I'll put this here. Remember, paste, special, enhance meter file, and there's my second one in place. I'm going to put a third one in place down here. So let's do the third one. So again, it's Control C. This time I'm going to use the shortcut, the keyboard shortcut. So let's do that. So I'm going to go Alt. You can see that home is H, so I push H. I then need to push V. You see how it says V under paste, so I push V. There's the paste. I need paste special, S. And finally, I need to just use the down arrow to get picture, enhance meter file, and I click enter. Now that is a lot faster. If you get used to that keystroke, you can do it in one single key sequence. So when you're transferring a lot of graphs, it's a lot quicker than using the mouse. So that might be helpful to you. Right, so I've now done those set of graphs. I will now just do one of the standard therapies. So I'll switch back. This is actually, I think, layout 6 is standard therapies. There we are, they're all standard therapies. So again, Control C, switch back, and then it's Alt HV S, down, enter, and there's my standard therapy. So you can see now I'm starting to add the therapies that I wanted to add. Now, let's imagine that you're handing this file back to a scientist, and let's imagine this is a high content screening experiment, so you also want to show images, various microscope images of the cells from which the data is derived. You can also add an image page, and I just do that here, so add image page, and you can see that it puts the image pages after the graphs but before the statistical summary. It changes it to black because in general fluorescence microscopy looks better on a black background, and it just puts default blue channel, green channel, red channel, far channel. We don't need those defaults, so I'll just take those out for now. And what I want to do now is paste my images in. So in fact, I haven't supplied any real images for this experiment. But I have supplied some images with the program if you just want to play around and put some images in there just to see what it looks like. So the way I'm going to do this is I simply go Insert, I want Pictures, I want to place them over the cells, not in the cell. I'm going to go this device, and I'm going to go back to Documents, which is here. Remember, I have my shortcut to Platemaker Wizard Data, and I simply go Tutorial, and you can see there's 4 micrographs I've provided just to play around with. These are lovely fluorescent microscopy images, so I'm just going to pick all those images, click Insert, they all drop in, and then I'll just move them around. This is the exact images that came. You'll see these match the images that were in the demonstration workbook, which is I'll show you on here. There they are, and I've just put example of an image page, so let's just type that in here, example of an image page, and I think that should be in bold, so you can see I'm just replicating now the way that the other workbook looks. So there we go, and that's the images in. So now if we compare this with our demonstration workbook, we have our heat maps, we have our graphs, we have our images, we have all these other pages. So the very final thing to do is just to create this index. So let's go back to our own container workbook, back to the experimental details page, and it's as simple as anything. We simply go add-ins, we go across to Platemaker, and we simply say create index, and it's done the index. And now we have our index, which is exactly the same as this index, and you can see it's all in there. So there's our images, and we can switch to our statistical summary. In fact, we have one extra heat map page, because remember I did 2 heat maps in the tutorial. But besides that, it's exactly the same, flat data. And again, if we go here, flat data, and there's always a return to index, so you can very easily now navigate the whole workbook very, very easily. So that's it really. So the good news is we've pretty much done 2 fairly big exercises to really get to know the Platemaker Wizard inside out in terms of all the functionality it offers you after you've built a container workbook. So I hope you have enjoyed this tutorial. If you have, please do give this video a thumbs up on YouTube. You also might want to subscribe to this channel as you watch the other tutorials, as that will also help the algorithm for other scientists to discover this really great program that can help you in terms of your biological data analysis. Okay, so I will see you in the next tutorial. Have a great day.